Hi, my name is Bob Grenier, and I'm a volunteer with the Martin Fleischman Memorial Project. So welcome this 7th of December 2024 for O-Day Unification. Can everyone hear me? Can they hear me? Just let me know. I've got something going on in the background here, so I want to kill that somewhere. Excellent, wonderful. Sorry for the delay. I had to pack and get ready. I'm going to Canada tonight. Why, may you ask? Well, I've been wrong a lot about this particular set of dates between the 10th and the 14th of December. I said it's when Betelgeuse aligns with the Earth and the center of the black hole at the center of our galaxy. That actually is true at some point. That would be a major event. However, it's actually, according to Parr, when the Earth goes through its maximum flux of ether. And so I'm going to be attempting several experiments that Nikola Tesla did in Canada, and we shall see if they're successful. But if you don't try, you don't know. There we go. Right, so what was I doing? I was killing something that was going on in the background. Right, good, done, dead. So I chose this image, or rather I engineered this image. And for those that hadn't guessed, it was done with AI. It is very clear to me that Photoshop AI is practically useless for creating certain types of images. And so I subscribed to Grok a couple of weeks ago and found that I had more luck with my prompts in there. However, there was quite a lot wrong with this image, and it's only a square format, so it cropped it off kind of somewhere down here and somewhere down here and so on. And that's okay. It's a good starting point, and using hand painting, more AI, extension in Photoshop, and corrections, I was able to get the frozen yin that I was after here. Now, I argue that if we accept Shishkin-Carroll's and Dubovic's model, the shell model of the atom, or something similar, that there is this hidden energy within that matter, which is this magnetotoroelectrical radiation, this cluster of relic neutrinos that the Russians call background neutrinos, that this has been condensed in the formation of that baryonic matter, whether that occurred at the birth of the universe, it occurred in a supernova or a black hole, or it occurred in an exotic vacuum object from another era, does not matter. It has these three components: the baryons, the protons, and the neutrons, the electrons, and this relic neutrino toroidal cluster. So in the formation of condensed matter that we exist within, that realm that we exist in, that we are made of, this bag of crap that I like to call it, that our spirit is able to possess and occupy, the process of creating that condensed matter required condensation of some amount of relic neutrinos from the overall field, that superfluid condensate that's out there, this rarefied medium. And so the yin character I have here is maybe the force, the life creating force, and the crystals of ice around here are representing for me the magnetotoroelectrical radiation around the force that caused them to condense. And so to engineer, in my view, the process that we're going to be looking at today, we have to release this condensed matter. Now, you can capture it from the environment using magnetotoroelectrical clusters in the form of electrons in fractal toroidal clusters and their cohering powers of their fractal toroidal moments. And we know that this can also disassemble matter, depending on whether that is a yang in that case or a yin is assembling matter. This already occurred to make the ordinary matter that we exist from. And as I said on my discussion, which aired before this stream tonight with Griffin Brock, who, by the way, is a fantastic chap. And we'll show a little bit of his website, a couple of clips from his presentations regarding this particular electrode that I analyzed. There is this belief in Russia that there is a vast amount of this rarefied material in every single atom. So if you want to put this system to work and you were choosing between rarefied material to get it going or the hidden energy, this condensed matter already within ordinary matter, well, you would want to start with the dense source of it, which is in ordinary matter. So there is some disagreement with, for instance, Shishkin and Parkhomov as to what is the source of the catalyst in low-energy nuclear reactions. But both of them agree it is due to weak interactions predominantly. And on the Parkhomov side, he's saying that this is captured from the environment or can be synthesized by over 1,000 degrees centigrade kinetic collisions in matter by heating it up. Shishkin, Karols, and Dubovik argue that you need to hit matter with any intense energy shock. That can be cavitation shock waves, that can be a gamma ray, a disruptive discharge, all of these different ways to incredibly shock matter, and you can cause it to separate into these three components, and you get a much higher yield of this material, this radiant energy, or this foundation for static electricity, this structure that can be used in order to affect low-energy nuclear reactions. So you can go and read Shishkin's work that I've translated on my blog with his permission, and you can see the details around this and the calculations and so forth. If you want to understand Alexander Parkhomov's work, you can go and read Space, Earth, Human, which I translated in 2009. And for those that are not aware, we will be doing an update of this book, Steps to the Discovery of Electronuclear Collapse. And thank you to the 100 people that have already pitched in with pledges to support that work. Thank you, thank you, thank you. It's very humbling. We are now over the cost of gathering the materials over the last several years to date, and it's all going to go ahead, but it would be great for others to get on board and help this science move forward. So the idea of this character here is that she, through her yin force, has condensed this rarefied material into ice. That is condensed water. It's the water of life that I'm talking about. And she's waking up. So she's got a little bit of color in her cheeks and so forth. And the material is starting to flow. And then she's fully awake and she kicks the water out and it's flying around the place. And so that was the concept behind that. Had quite a bit of Photoshop to do to fix things that looked a little bit wonky. and freaky. But that is pretty amazing what machine learning can do these days. So as you may have heard, if you didn't, the history of this electrode was that it was run for 15 hours over a number of days in continuous blocks. The discoloration occurred between the 9th and the 15th hour that we are going to look at in depth. And he found that there was no way he could deal with oxidation occurring, after which the electrode stopped being optimal. Now, as we know, oxygen is the most abundant element in the crust, and I would argue that low-energy nuclear reactions would produce oxygen, and therefore this might be an intractable problem unless you have something that is going to be able to suck up the oxygen that's produced at a higher rate. Now, through the history of LENR, there have been episodes where people have observed nuclear emulsions or other forms of film getting exposed when running experiments. Thank you very much, Gary Johnson. That is very, very much appreciated. So I'm just giving a couple of examples here. Many of these I've talked about in the past. The first at the top, of course, is Dr. Takaaki Matsumoto, a nuclear radiation expert. And he observed in standard palladium, deuterium, and nickel hydrogen electrolysis and pulsed electrolysis work, all kinds of tracks on nuclear emulsions, which are non-standard tracks. These are not from beta particles, positrons, they're not from neutrons, and they are not from X-rays or other high-energy photons. In the case of Caraboot, he used a laser. And interestingly enough, one of the experiments he did was he hit beryllium, which was one of the elements that was selected by Nikola Tesla in the formation of his radiant energy, for which he was able, or with which he was able to create these shadow graphs. So I would recommend you go to lenacanna.org and read about Caraboot's work. In the case of Vysotsky, he's worked with, I think, Alla Korlinova and others between Ukraine and Russia over many years. And he's done a whole bunch of cavitation experiments. And these produce the normal kind of blue light that you get to see. Maybe this is blue shift light because of the fractal toroidal geometry creating a change in the dielectric constant of the physical vacuum, resulting in a change in the speed of light, which, because the dielectric of the constant, the physical vacuum, the permittivity of the vacuum is changed, you get infrared becoming visible and visible becoming UV. So maybe that accounts for the blue light, but they also observed exposure to films in what looked like co-limited radiation coming from a water cutting tool. That is where you're cutting metal with a high pressure water jet. And he also observed some fogging with cavitation coming through a capillary tube. I think that was not with water, that might have been with an oil, but you can go and look again on lenacanna.org and search for Vysotsky, or you can go to LENR events on the MFMP's nanosoft.co.nz and put in Vysotsky's name or Caraboot's name and find these particular pieces of research. Vysotsky also had another theory that potentially, or another observation, that potentially it was thermal waves which were coherent. So this was coherent thermal frequency, i.e. that is coherent infrared radiation. And that's interesting, and something else to consider. Or was that a direct effect or a secondary effect? Don't know. One of the more famous ones was during early palladium and deuterium research. Babratomic Research Center, this was right the way back in 1989, using palladium deuterium. They also observed fogging of X-rays, of X-ray film or radiographic emulsions. Piantelli's observation, which was slightly different, he told us this in January 2015 in person. His company was called Niche Energy. And back in 2015, I suggested that that was because it was nickel, carbon, hydrogen energy. Because I said that Piantelli doesn't do anything without having a specific reason for it. And he literally had capital N, little I, which is the chemical symbol for nickel, capital C, capital H, capital E, energy. And so obviously energy is just the word. The rest, I think, was 3 different elements that are in his system. Anyway, he said to us in 2015 that when he turned on his reactor, he got a burn on his shoulder. So the suggestion was it was some sort of coherent radiation that was coming out at turn-on time. And I think it was even through his clothing that he got this burn, through the quartz pass-through where all the electricity and sensing goes into his reactor. We saw some radiation, which we initially called gamma, in October 2013 in Chilani wire, when it was leaking down from 3 bar down to 1 bar, from the operating pressure down to, thank you very much, Weird UK, thank you very much. And essentially, we'd established that this couldn't be X-rays, it couldn't be beta particles, it couldn't be alpha particles. It definitely wasn't neutrons because it was the way it's interacting with the scintillator tube. So we suggested it was gamma, but a long time later, we believe that it is these clusters. So it's a similar effect. So effectively, every time we were regassing, we were restarting the reactor. So some radiation was coming out and it was able to interact with the scintillator. Sorry, not the scintillator, the ionization tube in the GMC 310, I think it was, detector. Neil Crichton Gould's experiment were possibly, for me, one of the most important, because what you're going to see tonight is 2 triangle shape-ish structures that point to a kind of central location. And we found a lot of these on Neil Crichton Gould's first Lion reactor crust. And he was doing palladium, deuterium, and carbon. It was diamonds that I'd suggested at the beginning of 2014, in part because we saw diamonds forming on the Chilani wires in January 2013. My colleague Mathieu Velat in France under SEM observed these diamonds forming. And so we thought potentially the carbon could have been playing a role there. And I suggested using nickel and there should be nickel in here as well. It wasn't. In fact, I'll come back there in a minute. Let me just fix that. Silly me. That should be nickel, deuterium oxide, and carbon. There we go. Fixed. Plus, we also saw X-ray structures produced from the cold reactor on X-ray film, or rather, structures formed on X-ray film from the cold reactor. And so, and they were in line with these 2 spots. In fact, I saw the 2 spots first and predicted that there would be these mirrored structures, and there in fact were. And then the last one I will refer to here is Alexander Shishkin and all of his colleagues, again in cavitation, but they have observed these fogging materials. Now, you can go and look at my presentation, A New Form of Penetrating Radiation. For convenience, I have linked it into the blog referring to this particular presentation. But Shishkin believes that the radiation that Charles Glover Barkla, that is the guy that won the Nobel Prize for discovering characteristic X-rays, and these are the things that we use in order to determine elements using EDS, which is what we're doing when we're analyzing this particular electrode. He found this thing that he called J radiation, and he didn't know what it was. It was able to go through material as if it was very hard X-ray radiation, but it had weird properties, and he called it J because it's below the K shell or whatever. Anyway, he never really worked out what that was. There was a guy called Ivan Filimonenko in the 1950s. He, under classified Soviet research, did a palladium deuterium boiling water reactor, and he found that it emitted a radiation that was able to do some effects on radioactive half-lives. In my video for Space Earth Human, for Alexander Parkhomov's book in 2019, I go through a whole other series of authors that observed effects where in cold fusion or ball lightning or exotic vacuum object research, there was a change in the behavior of radioactive half-lives. I didn't add on to this list here Kladoff, but of course Kladoff found that he could remediate cesium-137. I didn't add on to the list the work of Roy Shinomasa, who found in the early 2000s, I think 2003, that he could cause the decay of cesium-137. And this kind of work in cavitation in both cases was verified by the Russian hydrowave technology, which is predominantly a cavitation device, in 2006 and 2009 in two separate devices. And so we have a means by which something is able to be released from matter that comes out. It would appear in a toroidal structure that can further cluster, and that this is neutrino-like in that it enables weak interactions such that radioactive nuclides that are beta emitters are forced to decay. So with that said, I'm just going to show you a few things about Mr. Brock's tube, and then we'll have a deep dive into the data. So just give me a second. I will pull up his website. So I have immense respect for Griffin. I love the fact that he's taken a kind of like 19th century photo and then colorized it. It's wonderful. And all of his writing seem along this kind of path where it appears like he's writing as if he's you're reading from a 1800s patent document or a journal. Absolutely wonderful. And I will show you, in fact, I'll see if I can dig it up here right now. Where are we? Give me a second. Yes. Okay, here we go. Yes, no. Huh. Okay, I'm just going to have to edit that. It gives too much away. Are we double dating at the moment? Right, okay. I don't think I'm giving anything away by showing this. So this is the rather lovely letter that he sent me, which is in line with, you know, his other kind of work, the way he comports himself, I shall say. It's absolutely wonderful. Why is that not allowing me to go full screen? Okay, that's tedious. All right, we'll save that. Nearly there. Okay. This is his letter. G.G. Brock Laboratories, with this wonderful little symbol here. It's a PO box, so I think I'm all right in showing this. Dear Mr. Grenier, it has been brought to my attention from a fellow colleague by the name of David Boutlier that you may be of assistance in the metallurgical analysis of an electrode sample for one of my 1A21 high vacuum tubes. Mr. Boutlier has expressed your interest in the matter as well as the accessible scientific equipment at your disposal, which may lend to such research efforts. I have enclosed a rather worked electrode sample in this package, which has been subjected to heavy particle bombardment over the operational existence of the tube it was within. This electrode was not surrounded by any special gases during its operation, nor was it secured to any other metal besides that of nickel. Given its 6061-T6 type aluminium alloy, it should not exhibit any erroneous metals other than traces of magnesium, iron, etc. Less than 1%. That said, I would request that the utmost attention be paid to the analysis of the tarnished face of the electrode rather than the opposite side of it, which has seen minimal bombardment. The former being the site of the greatest particle impacts and the most probable area of metal which would exhibit any unusual aspects. If you may, upon completion of your analysis, send me a copy of all relevant data acquired via the postal address on this letter or via email to, this is on his website, that's not doing anything. I keenly anticipate your results. Cordially, Griffin G. Brock. Absolutely wonderful. And I love the fact that it's essentially typed as far as I can work out. So I thought that was totally delightful. Okay, so the electrode, do I have it here? I might have it here. Maybe I don't have it. Yes, I do. It's in a little box here, which I showed you last week. And inside the little box is another little box. And the electrode is so packaged. And I didn't look at it until I was actually in the SEM place. And as soon as I put it on the stub and started looking at it with my camera, I could see it had the telltale signs that there was a magnetohydrodynamic structure on there. And oh boy, was there. So I'm going to pull up a piece of software here, which I will share this data. And this data, you'll be able to measure features. You'll be able to go around if you've got a PC. So that is the requirement here. What are we looking for? That. Okay, so hopefully you can see this. So this piece of software allows you to, in fact, firstly, I'm going to adjust you can go to the metadata here. And, oh dear, that's a bit big, isn't it? Okay, no, that's not going to be, okay. Right, so you can actually adjust the contrast of it so that you can see features a little bit easier. Let's try, maybe that's a bit too, you can see it here in a sec. There we go. Okay. So, the overall size of this structure, and you're going to see, you can see here 3 millimeters. So this is the kind of main magnetohydrodynamic structure, and you're going to see that in Photoshop in a minute. But you can see this is really rather large, and I think this is of the same scale as the 12 millimeter cross unit that was found on the Lion reactor. So here we go. We have these weird structures. We're going to see this in a lot more detail. And these lines going everywhere. And over here, this very interesting structure with these lines going everywhere. And on this side, we have these kind of like flow patterns coming in here, which are really rather remarkable. And over here, and over here, again, the same kind of things flowing in, flowing in, flowing in. And like we've come to expect, there's typically more action observed on one side. Okay, so I've done a lot of work in Photoshop these last several days in order to help people see what I have seen. And so we will go in there now, and we can come return back to this at different exposures. Okay, hopefully this is going to work. It's a rather large file. You'll see. Hopefully, this is clear. Okay, there we go. So I've got a slightly different exposure on this. This is a map that's produced by the mapping system. You can see it's taking little tiles and stitching them together. We've got far higher resolution images of these kind of areas, some of these areas, and so on. But if I overlay the magnetohydrodynamic structure, it looks like this. Okay? And so within this side, you can see these areas here on the periphery between this line and this line. Curving in, curving in, curving in, vectoring in, vectoring in. Okay? So these are all kind of vectoring into whatever this is. Up here, you've kind of got these lines coming in and branching, almost like lightning branching, but also like filaments in the cosmos or mycelium. Very much like that. Now, outside this part of the Vesica Pisces, you have it sweeping in here, this sweeping in here, this sweeping in here, this sweeping in here, kind of sweeping in here, directionally up here. This down here is absolutely ridiculous. Look, where this part of the curve comes down here, and this part of the curve comes down here, you have these fronds coming in. And they stop on these lines. It's mind-bogglingly precise. Mind-bogglingly precise. Now, what I was talking to him about is, like, if I come up here, look, right, on this side, if I take out the sacred geometry, you'll see there's this area, and then this area which is very different, and then this area which is very different, and then this area which is very different, and there's a little bit of a zigzag around here. Now, if I put in the sacred geometry, This is where the inner tor is. That's where the zigzag is. That's the damage on the inside. This is the different area here, and this is the different area here, and this is the different area here. It's utterly precise. Again, over this side, all these features are in here, but this area around here, you can say that is vectoring into the center. That's kind of vectoring into the center. This is vectoring into the center, 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 approximately. Okay? Now, if I turn this off, you can see all of the damage is enclosed inside the circle, right? Except for this bleed out here. They have this tongue out. And this is this particular shape we've seen many, many times. It's in the Solin patent from 1991 for his quantum coherent nuclear reactor. So you have this area, and then this area. Absolutely, totally precise. These structures tend to come to this central point and up here and within this circle here. Now, I thought initially that this may be because of the spot welder. But I'm not so sure now, because if I change this to the magnetohydrodynamic structure captured on the tungsten with a maser gas here, you can see that the damaged area is predominantly on this side coming down here. If I take it out, same area marked out within reason. Same area marked out round there and up there. Okay? Same area. Now, when it comes to the area in the sarcophagus in the Great Pyramid, I have said that it is this kind of area here. And if I take out the sacred geometry, again, this is when you look at this, and you'll see it in a minute, it's kind of like a triangle there and a triangle there. Okay, it's not quite perfect. But this is the area here that would be in the sarcophagus. Now look what it is on the ultra. This is the positioning on the ultra. So there's the sacred geometry. You've got the material coming up here. This is where the lighter elements are. This is the yang. It's taking matter and disassembling it. The yin is over here. This is where the heavier elements are. And if I go back to Griffin Brock's, it's doing stuff here and then it's pushing it over here. Now, I took, with the Laura lens on the Sony Alpha, some optical imagery to go with this, and it reveals something absolutely striking. Here we go. You ready? You ready? Boom! Okay, so we got a color structures here, but what you can see is that not all of these elemental layers are changed, and we're going to have a look at what these are in a second. Okay, so you can see some of them are revealed and some of them are not revealed. I will take out the sacred geometry here. You can see more of the actual structure here. So you can see some of these are here. Now there's a slight distortion on this lens, and so it doesn't perfectly represent it. You see how many lines you can see and can't see relative to the different viewing techniques. So a couple of these lines over here are quite clear, but I'm only seeing one there, one there, one there. And if I punch that out, oh, there still is only one there. I chose a bad example there. Okay, look at this area here. See how many lines you can see. And we will chuck in this. And in fact, yeah, there we go. So you can't see so much. This is on the Laura. Now the Laura is quite tight, and I would have had to have worked hard to get this to tile in. Have a look down here as well. Now, before I go forward with more imaging that I've done, I'm going to have a quick look at what the elements are in these various areas. So here you can see there's many of these lines here. And when we go to the color image, there's not so many being very obvious. So what this tells me is that in some instances, like for instance over here, you're only seeing some of the structures that are on the surface. The SEM is able to penetrate the surface layer and see X-rays coming back, characteristic X-rays from the material underneath, showing whatever this is. And we're going to see what this is in a minute. Okay. So we'll come out of that, and then we'll just go to the video, and we'll see some of the video. There's a lot more imaging to share with you in a little while. Stuff that took a lot of work. But well worth it for this particular sample, for sure. That's not what I wanted to do. No, I don't want to do that either. I did this so easily earlier. There we go. Right. So this is more of the session. I haven't properly done the titles on this, so I'm showing you it here now. We're going to look around the sample. There's various areas looked at here. So these little flecks, this is very like I have seen on one of the Hutchison samples, the fracture sample. These central flecks here are rich in copper. Okay. And I've seen this on a number of Hutchison samples where you get these regularly spaced pieces. Okay, they are extremely regularly spaced around this vortex structure. And it's high 22% in copper. Now, is that copper that came from the electrode? This is why I'm asking Griffin to produce one of these electrodes without touching any copper. So there's the image of this area. You can see how regularly they are spaced. So I unload the sample and I've rearranged it here. So this is the key part of interest here. This particular area here is exactly and precisely in the zone of the formed boron in the ultra experiment. And it is quite amazing because it has this triangular structure. Well, I will go into the triangular structure in a minute. I'm just zooming around here a bit. We analyze that, and again, that's rich in copper. And this area around here is in iron and nickel as well, and manganese. So I'm going to look at this overall sample area here. Now look at this. This ejector from the center of this triangular structure, which is in the same place as the synthesized boron, is carbon, oxygen, sodium, magnesium, aluminium, silicon, sulfur, chlorine, potassium, calcium. These are stellar synthesis elements, just as we saw spewing out of these apple-shaped magnetotoroelectrical cluster structures in Binge-Wen Huang's reactor. The same elements. Look at that. That is absolutely beautiful. Very tight peaks. Carbon, oxygen, sodium. This is magnesium. It's not in the list there, but that's what that peak is here. Aluminium, silicon, sulfur, chlorine, potassium, calcium. This is the flower of life. This is coming out of the same point in the structure. This would be, it's raised on one side and comes down the bottom on the other one. Okay? Just to make that very, very clear, if we go back to Photoshop here, not that one, this one here. What I'm referring to, and we've just been looking at there, is this area here. And what am I looking at? I'm looking at the same as in the Ultra experiment here. This area here, okay? These are boron crystals. They're inside the Vesica Pisces, inside the golden ratio line, comes round inside the torus and emerges here. Okay, so in fact, very, very precisely, that is the triangle and these are the two fields. And this is the area precisely that I'm looking at and seeing the stellar synthesis at this point here. Okay, so I'll go back to that in the video. Okay. So that's that one. And then I look at the edge of this structure here. What is that? Well, this is iron, manganese, and nickel. Okay. Now we do know these things are highly magnetic. So it could well be that this is material that's pulled in from the rest of the metal sample. Whatever. We know the centers are magnetic. Anything magnetic is going to be there. Okay. Over here, again, iron and nickel in this fleck. I do a map here. We can see being born out of this stellar synthesis, there's a little frond of copper at the end of the line. The heavier elements end up being at the back end. Again, look at this. I am looking at the overall elements here. Carbon, predominantly carbon, just as Matsumoto observed. Oxygen, second up, only slightly less than aluminium. I think he's always going to have a problem with oxygen being synthesized and oxidizing the electrode. These things have a limited shelf life, but they could be reconditioned because the glass maybe doesn't need to be reworked. Okay, so oxygen probably synthesized, but the peaks are very clear for sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium. These are all the classic elements to be synthesized. Same as we saw in Bin Huang's reactor. I think I have a look at the, do I have a look at it? Okay, so this is actually, do you know what? This is incredibly amazing. Why? Because this is the dead center of where the Vesica Pisces edge and the golden ratio line intersects, i.e. where one torus intersects with one round intersects with the another one. I'm going to show you that in a second. And what you can see here, I've just changed the image type to SED, and you can see that there are these lines that are coming in, coming in, coming in, coming in. And what you are looking at here, these shapes here, these are the bits in between the tores. So there's a tor here, there's a tor here, there's a tor here, and there's a tor here, and there's a tor here. This is just what we saw when we first found the structures that led to the fractal toroidal geometry on the Hutchison fracture sample. Okay? And so what I mean by this, you will see on Photoshop. So I'm going to switch back to Photoshop now. And we will go over to the center here. So what I'm talking about is the intersection between the Vesica Pisces and the golden ratio line. Whatever that is actually the center line. So it's actually across the center and between the center of, sorry, the outer radius of this and the center of this. That is the intersection there. So I'm going to switch that out and you'll see that is what we've just been looking at. And you know what? I've got a higher resolution version of that, which I'm just going to drop in here. There we go. Okay. So there we go. That's what we were just looking at. And that is right in the intersection between the radius of the overall structure on the magnetohydrodynamic structure from this one and the center point of this one. Totally and utterly precise. Nature does not get this wrong. It has one way of doing it, and if you work in this way, it's always going to be easier. Always going to be easier. So I have this at higher resolution over here. Okay? So this here, you have the golden ratio line coming through here, and so this is the center point of that circle, and you have a hole here and a hole here. A hole here either side of that. I'm not sure what that is yet. I'm not sure what that is. What is this hole? What is this hole? I think this is where you get, when these things blow up, you will have these twisted coherent matter beams coming out of this area here. This should be where, like, you can actually see from down this point, there's a hole here and there's a line that comes up here and then it curls round this bit. Line comes up here. We're going to learn so much from this sample. Even where, for instance, here, you have these sections. When you come over here, they're still there. They're cracked. Look, there's a crack that comes up here and a crack that comes down here, and then a crack that comes up here and a crack that comes down there, a crack that comes up here. So even for the rest of the tool, it's there. Now, I'll take that out. And we will go back to the video. This is a pit. We can see it's a pit, and also over here, you can see that this dips down in here, dips down in there, right? So I'll go back to Photoshop and I'll show you this in more detail. We have the yin here, which I've just showed you, but in a slightly higher, about an extra 50% bigger magnification, we have it here, okay? So this is BSD, backscatter detector, so you don't see the geometry so much. You only see the elemental materials. But over here on the secondary electron detector, you see the geometry. And look how it's going down into a crevice here, and there's a hole here, and there's a hole here, and there's a hole here. And look at these things coming out, these twisted filaments. There's another one up here somewhere. Look, almost looks like a strange radiation track. Twisted filament coming out. Look at this one. Twisted filament coming out. Yeah? These are coming out from essentially where you would have your number of tors. Now, how many tors have we got in there? Subtors? Well, I used the software that I've just been showing you, and in here, I did a calculation. So the first updater is this. The distance across the two fat Oreos is 10 millimeters. So from this point over here to this point over here, going through the center and going through the center. This is the center on this side. This is the center on this side. The overall diameter is 10 millimeters. It's almost precisely 10 millimeters. So the lemon is from here to here, so that is 5 millimeters. And the apple, for the whole structure outside of that, would be 15 millimeters. So I think that this structure organized itself to fit within the tube. Now we're going to go and have a look at the tubes before we move on to more analysis on Griffin Brock's website. You can see them in operation. It's absolutely beautiful what this guy has done. Congratulations to Griffin Brock. Okay, so I will skip through so we don't have any copyright strikes. So he talks about Michael Faraday first off, I think. If I could get my sound working, that would be good.
Which was little known at the time. The phrase radiant matter. What exactly is radiant matter? He describes it quite vaguely, not necessarily giving very much clue into what it exactly is, but nonetheless he brings about that it is likely another state of matter. And in around 1819, he gives another lecture in which he gives more definitive proof that the four states of matter comprise liquid, solid, gas, and radiant, photographing of electrical discharges, both natural and artificial. This is what they were doing within the early part of the 1890s, around 1890 to 1891. That we have pictures that were made by Jennings here of course, natural lightning, but also man-made lightning from various Ruhmkorff coils and what have you. Both Jennings and Godspeed were experimenting with a Ruhmkorff coil and a traditional cathode ray tube, which essentially comprises this setup. Now, one could only imagine that should these be regular X-rays, well, at 4 feet distance.
So this was Röntgen, but this was March the 11th, 1896. Tesla taking an X-ray of his arm using his material here.
We're working with some rather nasty exposures. But as we'll see in later articles, this starts to provide an interesting insight into just what these rays are and how Tesla was in fact working with a rather unique type of ray, which really has not seen light since his transmission of these articles during the 1890s. And we could see that although Tesla is deviating from his original single wire design, he's exploring and experimenting with other various tube designs just to see what he could make the most effective design and see what that really entails in terms of phenomenon and other photographic abilities. So these are some of the tubes, and these are some of the only surviving pictures of the walls of the lecture room, which Tesla had, of different photographs and drawings of tubes which he had constructed and which he was demonstrating there before the audience. And we could see truly elaborate designs, I mean, encompassing spherical and elongated proportions with alien design or alien shape electrodes of curvature, roundness. It's interesting just to see what Tesla was working with around the 1890s and how fast this research was developing. Now, to really sum up the presentation and really get into around 10 to the minus 6 to 10 to the minus 7, Tor was the working
he does the demonstration
here. The production of the radiation actually becomes stronger and stronger and stronger. Okay, and we should be able to project an image.
Just again, he styles himself on a 19th century scientist. He speaks like one, he speaks with the language of one, and he packages his packaging for his products in the same way. It's absolutely wonderful. I totally love it.
I will now turn the apparatus on.
So here's the tube, okay? Basically, it's an electrode with a nickel back, and there is the button, the kind of piece of aluminium. And I sense what is going on is you're going to get ion acoustic waves. Now, they have a spark gap, I think, in here. And if that's true, then it will be a disruptive discharge generator. And if that's true, effectively what it'll be feeding into here may be actually exotic vacuum objects anyway. But if it's not, and it's just high frequency, high voltage, you're going to get shock waves in the rarefied medium in here. And that is going to produce standing waves when you get the right frequency. And it will initiate a phase conjugation on the surface of the aluminium in exactly the same way as it initiates the phase conjugation on the surface of the aluminium in the ultra experiment. And then what you get is you get the yin and the yang transverse to the metal surface. This is exactly what we observe in the ultra experiment. This is a plasma version with plasma rather than, which is charge separated material, rather than the charge polar separated material in water. But ultimately, you end up with the same thing going on. Now, back to his presentation. So you can imagine that either EVOs are coming through and aggregating on this surface, or you've got these sound waves coming in, and what that's going to do is pull things away from the surface and smash it in, pull things away from the surface and smash it in. And so depending on where it is in the cycle, these things are going to get ionized, and when they're ionized, they're then going to get moved in and out more violently and more violently. Thank you very much, above all things. More in and out, and they're going to start smashing into the surface, and you're going to get these disruptive impacts that Shishkin is saying lead to the formation of the release, the defrosting of the water, the condensed relic neutrinos, what I'm calling like this third part of matter coming out and then able to aggregate into the overall structure which is forming on the surface. Same thing is happening in the ultra experiment. So, like I say, this is it's a demonstration of the effect, but it's more visceral. You can see it with your eyes. Okay, so we will go ahead.
You might want to shut the speakers off. Okay. And if all goes according to plan, you see the screen, and of course the CRT is receiving some of the static impulses because it's in close proximity. But if I were to place something such as my hand, then you could see the projection of the image. Now,
how
imagine
awesome
the fact
is that?
This could be seen at distances of 20 feet in excess is quite remarkable to think that this is not necessarily a harmful X-ray, but rather something unique. And the fact that we are seeing this for the first time.
Boom!
So what you just witnessed was the first public demonstration of Tesla's shadowgraph in over 120 years. Not even Tesla publicly demonstrated it.
Bada boom!
It is, you said.
Okay, so like he's definitely doing it there. It's definitely done in real time. There's some finessing that you need to get, and I think it's to do with you probably need to get the frequency just right. You just need to get it right so that the standing waves are set up, or so the harmonics are correct. And absolutely incredible. As he said, this is the first time this has been demonstrated in nearly 130 years now, and Tesla couldn't demonstrate it in this way. He had to, take X-rays or rather shadowgraphs himself and then show those. He couldn't do it real time because there wasn't the imaging technology to be able to do that. Okay, so absolutely amazing. I'm going to show one other video where he actually replicates some of Tesla's photos that he took with his shadowgraph equipment. Now, the interesting thing about this shadowgraph, when you see this next video, is he's actually using a intensifier screen, and the intensifier screen contains phosphors, and this is exactly one of the things that Tesla was using for maybe doing real-time observation. But it's the phosphors, for instance, silver-activated zinc sulfide, that are part of the shielding technology described in the patent by Alexander Shishkin et al. In my view, this is the same thing. So let me find that other.
Using the right.
Right, there, got some nonsense there, which we need to get through. Hi, David. So David Butlier helped me arrange this, so thank you very much. Yeah, I'll see if I can dig out the spectrum. David Butlier has done a lot of looking at this device with the radio code and so forth, radio scan devices, and have found that this radiation can travel a very large distance and can penetrate all kinds of things. So I think probably Brock, myself, and David should come together and put together an unbelievable paper, an absolute kick-ass paper, where the physical data is absolutely there, the real-time kind of X-rays is absolutely there, and the possibly the transmutation is absolutely there. That's why I want to work with him a little bit more to get this absolutely nailed. And this unique radiation process, which has been observed in cold fusion experiments. Like I say, in the Christopher P. Tinsley interview with Martin Fleischman in 1996, he is discussing about this type of radiation that many LENR researchers have observed, but couldn't explain, because it looks like hard radiation, but it's not hard radiation. This is one of the main signatures of low-energy nuclear reactions, without a shadow of a doubt. As I said to Griffin Brock, we may be able to use these tubes to point at radioactive material and remediate it. You understand what I'm talking about there? So at the moment, we have suggested using cavitation for Fukushima's nuclear waste, the tritiated water. We know that works, but they don't want to do that. I have suggested electrolyzing it and burning it, and we know that it will work with HHO and doing it that way. This is a third method where you can literally impinge upon the beta isotopes, and this can be verified with standard beta isotopes because we have a targeted beam that we can do. Absolutely mind-blowing. He's not aware that this could do this until I told him on Wednesday, but he potentially has a source here that can deliver a remediating beam. Okay, let me see if I can fix the audio again. It's gone quiet on me again. Okay.
From the earliest developments of the X-ray tube to efficient modern-day medical applications, the safeguarding of personnel due to X-ray radiation exposure is acknowledged as a required precaution. Endured exposure to X-ray radiation was noted in early development by historical pioneers including Thomas Edison, Nikola Tesla, William Morton, and so forth. Severe side effects inflicting the body were reported by such individuals of science, while operating vacuum tubes involving 2 electrodes made of heavy elements.
Okay, so this is Tesla's X-ray here. This is another one by Tesla. This is by Rontgen. You can see in many respects the Tesla kind of X-ray. So this is his...
which behave like X-rays.
Right, so this is Tesla shadowgraph from 1896. So here's, I presume, Tesla's foot. Doesn't look like an alien foot to me. It looks like a standard foot. You can see all of the nails in the heel of the shoe and the buckle points and the shoe eyes, rather, here.
Although do not inflict harm nor render radiographic imaging to short distances. This suggests that Nikola Tesla had a beam tube, which is...
So behind this label here, oh, sorry, there's the electrode. So here's the aluminium electrode, just like the one that I showed you earlier, which you can remember if you were there earlier. So the nickel wire is coming through here, and it's attaching to the back of this electrode here.
The first of its kind within the Desmitron vacuum tube series. It is of patented construction.
Good for him.
Possessing minimal parts and simplistic operation. The operating principles and explanation as to how this tube is an alternative to X-rays shall be presented in 2 adjacent videos. For now, we will concern the overall practicality of this beam tube. To demonstrate the rate...
So he talks about the device here that's creating the impulse discharge, the resonant coil here. You can go and have a look at this video. I don't want any copyright strikes here. So in this box, basically, he has a intensifier plate. These things are commercially available. And he then has a standard low definition CCD based camera in here. Something CCDs are good because they're global shutter rather than rolling shutter. So you get an old CCD, it's much better. I would suggest getting a TRV 900 if you can possibly get one, David, second hand, or it's PDX 10. I think it's the equivalent. I think I have a PDX 10 actually, because they're 3 CCD, but ideally you want a very fast response time, global shutter, normal camera, okay, that's quite sensitive. And then he has a CRT here that he's using, and he shows that there's interference because it's not shielded, and then he shows this multimeter being real-time X-rayed.
Radiographic images or fluoroscopy, we may place various objects in front of the beam, such as this electronic meter, or a denser object as this analog milliampere meter. A packaged box of vacuum tubes is no challenge for the emitted particles, even at great distances away from the tube. There being a lack of hurtful effects with the desmitron tube, one supposes the medical benefits of such a device. Likewise,
so these are his own X-rays. This is made at 3 feet away. I presume this is a fish. Very clear.
The industrial application of the desmitron tube allows for the...
I can only conclude this is a side profile of himself since it has his own glasses there. So he's doing exactly what Tesla did and actually exposing himself. This is 4 feet away.
Photographing of materials and objects at exceedingly distant points.
Beautiful, clear X-ray. You can even see the definition on the shape of the bones here, 5 feet away.
Unheard of with conventional X-ray methods.
And he's replicated Tesla's shoe shot here. So he must have actually found an old shoe to work with. I think it's absolutely delightful, this young lad, what he's done with this is beautiful. Very inspirational. I'm totally inspired by him.
See through human extremities at distances of more than 6 and 8.
Yes, David. If you go and look at the 1 hour 20-minute conversation which I published prior to this live stream, you'll see me warning him very clearly to be careful. Okay, but full on credit. He's even done a much better X-ray of his shoulder, or rather shadowgraph of his shoulder, than Tesla did.
Feet away, or enclosed packages at 15 feet.
15 feet away. Look at the detail in here. 15 feet away.
And more than, but not limited to, 20 feet away.
It can go 20 feet or more. This is completely compatible with what has been observed by David Boutelier in his experiments. David, if you could write into the chat what's the maximum distance you've exposed things or observed radiation emissions from this.
Impressions made on standard high-speed X-ray film display the remarkable attributes of the desmitron tube. While we are not dealing with damaging X-rays, but rather highly accelerated particles, there exists no bound to maximum distance which may be obtained with such a tube.
Okay, so that is his overview of it. And as I said earlier to him on Wednesday, the day after I looked at the sample, I'm going to be directing people. I'm directing people, if they have the appropriate equipment and they can take the safety precautions, I think that this process, this device, not only proves Tesla was likely transmuting elements, it is the radiation that is the thing that should be able to deal with radioactive material at a distance and remediate it. But it is a source of potential energy from that, because you can use, say, lithium fluoride, or you can use other, for instance, potassium. It's not that these clusters themselves have a lot of energy, it's that they can package and mask electrons and ions, but also that they can cause weak interactions. And if you have a weak interaction where you wouldn't yield much energy from that weak from the actual particles, but you can get killer electron volt or mega electron volts from the potassium 40 decay, you can yield a lot more energy out of this process. So someone says, so this itself is non-harmful. No, that's not true. The magnetotor-electrical radiation on its own, if it hasn't collected any electrons or ions, is less harmful. However, as I described in the video 2, Griffin, which you should have seen or can see in the blog, it went out just before this live stream. I warned him that this can transmute the potassium in your body and the carbon 14 in your sugar molecules. 1 in every trillion carbon in your body is carbon 14, and cause that to convert to nitrogen 14, which means it's going to smash up your DNA. Yes, he's a very impressive young man, and I wish him all of the best, and I don't even think he needs my wishing for him to have the best, because he's just awesome. Right, okay, so we're going to have a look at more detail on this electrode. We're going to have a look at, we're just going to finish out the SEM session, and then we are going to have a look at some more photography that I took and the implications of this all. Okay, so back to the SEM session. So this, as I said, was the center between the Visa Capices and the golden ratio line. It's essentially the way the radius one intersects with the center of the other. It's here at the point between these two structures. These lines coming in here are going under or in between the tores, and I believe that the gaps here are the shape that it's made in this overall structure when the tores are in position. Now, the weird thing is that they're moving things in the ether. They're like vacuum currents. They're not actually physical things. It leaves an impression in the material. And so if we're going to work out how much this is, we can use this as the center point and then draw radius lines out. And I've done that. And I've done it here. So just again, if it's going to let me do it, the distance across the two fat Oreos is 10 millimeters. So the lemon is 5 millimeters and the apple is 15 millimeters. And then if you go to the next slide, what I have done is I've gone from the center here through the kind of central point here, and from the center there through the, so it has this little notch here and it has this little notch here, okay? Because what's happened here is when the structure is finished, it's kind of like pulled back on itself. It's pulled back on itself. So this is a little bit distorted and this is a bit distorted. So I've gone to this central notch here and this central notch here. So you've got this triangular shape here. This would be a triangular shape there, kind of roughly. And we get 45 degrees, and that is for, well, as far as I can see, 3 sub-tor structures. And so if there's 3 in 45 degrees, 1 petal is 15 degrees. That means that there's a number of n-1 tors in this particular structure is 24, in my view. It could be 48, and there needs to be 2 to make one of these things, and it might be 1 that side and 1 that side, and there's actually 2 on each of these things. But I think in this case it's 24. We know 24 is a valid number for these structures. Anywhere between 2 and 48 is valid, so 24 is a good number. Okay. Back to looking at the Photoshop. Because I used the Canon camera with some macro lens and some photo stacking software, and using that I made a 125 images. So there were 25 different depths and 5 exposures per image, and we ended up with something that is really rather lovely. So let me show you what that is. Are you ready? Are you ready? Boom! There we go. Now, already when I look at this, I can see so much of interest. You have obviously a very circular structure here, and it's circular but not equidistant from the edge. It's circular in its own right. Again, this browner area here is circular, but it's closer to this edge than this edge. Okay? So it's not perfectly centered to the disc. It's where it wants to be, not where the disc might be confining it. And if we go in this a little bit closer, we can see here something that literally looks like an apple. I mean, it literally looks like an apple. We can also see these marks here. And I haven't shown you what elements they are, but I have shared the video where it analyzes those. So these are basically iron, nickel, magnetic fronds, okay? And I've got one where I've got it only partially, or rather it's overlaid. So this is the next image I'm going to show you is overlaid on the SEM. So here you can go, you can see I'm overlaying it. So that's the full exposure. So you can see here, yes, we are seeing these bits, but oh my God, we're not seeing all of them. So some of that iron is coming through and being seen by the SEM. Look at this. Look at this. It's like hidden data. Is it your birthday today, Phil? Happy birthday if it is. So here we go. We will look at the sacred geometry overlay here, and we'll look at the geometry here. Now look what we are seeing here. This blue area round here is essentially just outside this one, just outside this one, just outside this one. Yeah? The brown area is just outside this one, here, and here. Right on the edge, right on the edge, right on the edge. Okay? This being the apple. Moreover, you can see that this kind of orangey area in here is contained within the Vesica Pisces, but underneath this area here. This area, apart from this bit here, is slightly mottled in this area. Okay? I'm going to put the 50% on here. Again, I'm utterly amazed at this, what's going on here. How is that even possible, that these fronds would come in? And like, if you look at mycelium and those kind of things, these materials here are like these webs. They're just like the webs you get interplanetary webs and in mycelium and in neurons. As above, so below. Now I'm going to show you something else here. This is the a 3D kind of look at it on the Laura. And you can see that this is raised here and it's depressed here. So it's sweeping material up from here. And this is very much depressed. Okay? These are definitely impressions. That's the other magnetohydrodynamic structure on the Amasa-treated tungsten. And here is the one on the Ultra experiment. Okay. Now I have something what I call on the yang side here. Which is this. And that is, as I said before, where the Ultra experiment is. So this is where we saw stellar synthesis coming out of the center of this triangular iron material. So we know that iron and nickel will want to be in here because it's magnetic. This is the magnetic flux part on the yang side. And out of the center of that, you've got this spewing this material, which is stellar synthesis. All of those elements from the stellar synthesis. Okay, coming out of here, the same place that we saw lighter elements forming and heavier and lighter elements, because it's fusion and fission in its own right. So there we go. Exactly the same place. And then for those that missed it earlier, we had the yin side here, and I had the SED as well. So you can see here, right in the center. That is the center. It's interesting because the tour comes around here, but it's not quite, you know, the way it represents itself. You have this depressed area here, but actually I showed you earlier that there's actually there's still these cracks in the right place in the material. It's just not so obvious as it is on this far side. Okay. I think we'll learn a huge amount from this electrode. I can't wait to have some more time with it. Okay. Now, here's something that I have said for a very long time. That this area here is largely unaffected. This is what I call the safe area in the magnetohydrodynamic structure if you were to have to sit in one of these things. Okay? And if you look, this area is largely unchanged. There's these crack things going on, but largely unchanged from the other material out here. It's the same kind of mottled arrangement of aluminium with this iron contamination. Here, pretty much the same in this little part. Where is that part? Well, that is this part of the sacred geometry. Now, why is that important? That is important because of this, my friends. 3, 2, 1, boom! That, my friends, is where you need to have your passengers in your ARV. Okay? Because they don't get mashed up. Now, there is a central flux going through the middle. So you don't want them definitely on the middle. Okay? And I believe that they have the aluminium disc spinning here because any flux that comes up of these clusters that might interfere with the biology of the humans there gets caught by the aluminium and spun out back into the system. Spun out back into the system. Yeah? The ARV will float off the ground at this level when it's not so spun up. When it starts to spin up, it'll immediately go in the vector where the anti-gravity neutrino flux is going, in resistance to the flux coming down from the cosmos into the body of the Earth. Okay? So to make that very clear, I have here, you can see the grayscale, I overlay the color, and of course, what I'm suggesting is that, just to go over it again, you see this area here? There is a bit of manipulation of whatever's going on with these little flecks we see going around. Yeah, you see even they're on the color. Are they on the Laura? They're on the Laura, okay? But this area here is basically the same as the background. Thank you very much, Phil. Yes, we did get food poisoning in Ahmedabad. I was terrible. Oh my God. Yes, Phil, let's make that a wooden and faster than light device running on Steam. That's what I want to do. I just want to make it so freaking absurd. Okay, so there we go. You can't be in the center because there is a beam that comes through. There is a beam that comes through. Okay, whether it comes up or down doesn't really matter, but I think it comes from the bottom up. And so your passengers can sit on around the central column. That's it. That's your only option. Done. Yeah. Make it out of driftwood, yeah. And ground up lead paint. Whatever is the most absurd combinations, yeah. This actual model of the ARV is not accurate. It doesn't have the capacitor banks the right amount, but you get the idea. It's an aluminium spinning disc. We already showed in our work that aluminium is an effective partial shield to this, and Griffin Brock has confirmed that aluminium does do some sort of shielding, and he's writing a paper on that currently. And I argue that one beam is able to come out, but the other beam is getting stuck in the aluminium. And so you don't get a beam behind it. You only get a beam in one direction because the aluminium is effectively capturing it. Okay? So that, my friends, is basically what is going on with this system. It is synthesizing elements. That remains to be categorically confirmed, but I'm pretty sure it will be. Okay? This verifies that the magnetohydrodynamic structure in the core is able to capture or synthesize iron, because that's what it's doing literally in this core, and it is able to transmute elements in that core, in those flux loops, in the center of those flux loops, and the way that they work in the particular form. They're slightly offset and goes in one side and comes down around the other way, whatever. It is able to produce fluxes of this relic neutrino condensed matter. Some of it goes all the way around. Some of it comes out in a beam one way, and some of it comes out in a beam the other way. Now, there's one thing we need to resolve in this, and that is when you have the 3D structure on there, why are we seeing no disruption beam down here? Well, I think that is actually answered by the fact that if we were to draw a circle around here with the non-radiating boundary, it would actually go further out from here. And so what I think is occurring is that this oval structure isn't quite lying flat on the surface. And in fact, in Binjuan Huang's reactors, we often see these things crashing down slightly, heading into the surface at an angle. And it might be that that is just the way they represent themselves. And so I've got a 3D model here that I prepared earlier, although I haven't fully prepared it in the way that I want. But it might help you understand something about what I'm talking about here. If I can just fix it up a little bit. And I need the panels. Which panels do I need? Where are the panels? Oh, I've got so much data for this, it's ridiculous. It's been a fun week. I love it. Okay, I need my layers. Layers, give me my layers. Yeah. Why am I looking in modeler? No, it's layout. I can't remember why. Too many years away from Lightwave. That's my problem. I'll be with you in a second. I don't have layers in here, do I? I've scene editor. Because I'm not in modeler, isn't it? Okay, all right, fine. Such an idiot. Okay. So. I have for you here a 3D object. It's not my best object. It's just a disk of our disk on its background. Okay, can you see what it is yet? If you can imagine that, that is our disk. I need to add a null in here so I can rotate this as I wish. So let me just add a null. Shouldn't take that long. Right, I need to go back to this one. And properties, give me a sec. I'm doing some modeling, which I haven't done for ages. Oh, what am I doing there? Right. Oh dear, I should know where this is. God, too many years away from 3D modeling. Don't suppose any of you guys can help me. I'm looking for the parent in place button so I don't have to move this. Let's hope it's already there. Let's see if it works. Does it move? It doesn't move. Excellent. Good. So I can move this now. Can I move this now? Oh, perfect. That'll do. Excellent. I've done it. More by luck than judgment. Right. So what have I got? I have our yin. So I have our little yin tors here. Okay. On our structure. And I have our cone here. Let's put the cone in. I'll put that in as a wireframe. Now, the question is, why are we not getting the expected interaction in the notch of the Sothic triangle, well, I'm going to put the apple in as well, and we're going to have this nice and greenly shaded here. Shaded solid, there we go. So you can see where the apple is interacting with the surface here. Okay. Right. I think that what is going on here is that the structure, thank you very much, Beninator, the structure is found resonance such that, like Tuchanov in his ball lightning reactor had a quartz sphere, and quartz, or even the borosilicate, will get charged with electrons that are coming off the overall magnetohydrodynamic boundary of the non-radiating boundary. And it'll force it to be pushed away from the charge on the quartz such that it is kept within that structure, as long as it's energized. And so I suspect that the little electrode is slightly offset, or the standing waves within the tube are such that it positions the overall magnetohydrodynamic structure offset, and so that it gets bound, and maybe the plate isn't completely parallel with the direction of the sound waves, it's slightly offset. And so in this case, I think that's some of those combination of things, because of the hand-built nature of this, are leading to the electrode being presenting as it is. And so I'm just going to do a quick rotation here and show you what I think is going on in this. Is that if I go here and I rotate this, the actual structure is something a bit like that. It can be anything. It's not dead center. It's kind of slightly off. It doesn't need to be by much, and you'll still get your beam effectively coming out in a pencil, but it won't be directly orthogonal to the plane of the overall, or in line with the plane of the device itself. So I think that's probably what's going on. And then the second issue we have is, where is the non-radiating boundary on this? Well, we can drop that in there, and I'm going to put it in a mesh, but it's going to be a bit nasty to look at, but we're going to do that anyway. So outer shell here, wireframe. So we can see that when we rotate this, such that it's a little bit off. Now I've got the non-radiating boundary slightly in the wrong place. The non-radiating boundary should actually be on this edge. In fact, there's a double there. It's between that point and that point, actually. So that's the way it is. But you can imagine that whole sphere would largely be bounded inside the tube. Okay, so you've got the glass tube around here, and it might just be that helps it stay in the location it is. I think it's a combination of the factors, and only by studying more tubes can we be sure. So we'll hide that, and so that is the my view of what is going on. If you want to see where the Tor goes, well, the Tor is going here, like that. Yeah, it's going around the back, but like this is your phallico. And so the cones, one will go in and one will come out. So if I get rid of that hidden, and we put in our yin cones here, yin-yang cones, like so. Is it going to do it? Yeah, are they there? There we go. So only one is coming out, because the other one is going that way, right? And that will produce a beam, because there's not 4 structures, there's only 2. I'll get rid of the apple now, hidden. Okay. And I will make that a shaded solid. Okay. So there we go. So one will come out. And that's it. That I think is what's going on in Griffin Brock's device. And as he said, when it warms up, when it's starting off, it's got a wide beam, and then as it warms up, it gets a tighter and tighter beam. And so I think what is happening is he's building up the scale of the substructures here, and as this substructures get up to being a tight multi-tor structure, when we've identified it might be 24. Then you can then get the beam coming out. The other one is going into the page, into the aluminium electrode, and so it just doesn't go anywhere. It just gets stuck in there. And so that, my friends, is about that. If you have any questions, now would be the time to ask it. Before we go out, I've got some Hutchison samples to show you where we observe the same kind of iron and copper synthesis in these pits. And I've never shared this before. And so here we go. Let me just get that. And I'm hoping to replicate some of these observations in the coming years. Right. So I actually have this sample in the drawer here, as one would do. Let me see if I can get it out in one piece. No, I can't. Stuck together, and oh, maybe I can. Here we go. All right. This is this sample. It's the end of a particular piece of metal here that I cut off, and it was given to me. It was from the early 1980s period of John Hutchison. Never been analyzed before. I've actually used some of the analysis images in the background of presentations that I've done in the past, but this is absolutely spectacular in my view. Thank you very much, Scoggy Hoggins. How can others reach you if you're also working on projects like Griffin? Thanks, Bob. Remoteview.icu can send me a private message there. So here is the sample under the SEM. And then we look around the sample, and it has these scallop sections, which we've seen before. And when we look at the scallop sections here, we can see these little central spots. Sometimes this is pentagonal. In the center of each of these little scallop sections, there is a heavier element here. Boom, 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 boom. And then this is a real extreme close-up, so you can see what's going on here. Again, this pentagonal shape here. More of a hexagonal shape here. Some of these are covered up through time. This is SED, so you get to see the depth going on here. But what you're not seeing is the elements which you see here in this one. So in this shot, it's a mix between SED and BSD, backscatter detector. And you can see here something very bright in the center, even brighter than these things. Right, let's have a look to see what we've got in this structure. So what have we got? Move that over here so it's not under my mugshot. So bearing in mind this is a bulk aluminium sample, we have oxygen, aluminium and silicon. Just the same things that we observe in the system by Brock, but we also have iron, okay? Iron in here. Now, silicon can be formed from aluminium, put a proton in there, and take 2 silicons and you fuse it and you get iron. So this is a John Hutchison sample. The little things in the center have iron and silicon in them. If we go down and look at the background petite pieces, it's carbon, oxygen, aluminium, and silicon. Okay, so there could be trace amounts of silicon. That's on the ridge. Okay, but again, we're seeing oxygen in this case, whereas, yeah, we got the oxygen there as well, of course. Oxygen's everywhere. Gonna have a look at another one here. Again, iron, 10.9% by weight. Another one here, iron, 50% by weight in that little sphere there. Okay. Now, what is this one? What is this one? What do we see on the Brock electrode? Well, look, we have sulfur, phosphorus, and we have copper. Look, 44.824% copper. So, the interesting thing is here, this is like little spheres or little substructures all over. And then in the macro structure, we have in the center of that an even heavier element. What else do we have? Nickel. We've got nickel up there as well. The other ones didn't have nickel in. It's just a little bit of nickel. Add a proton into iron, you get nickel. Yeah? Or a couple of protons, whatever. Proton. Go on. Again, it's much of the same, silicon and copper. There we go. What is this one? Lots of copper, 21.5% copper. We got some magnesium in there. Cesium? Nah, I don't think it's cesium. That's a fake signal there, not cesium. However, we've got manganese in this one. That could just be a contaminant. This looks like a fleck that's been caught on the surface. The other ones are bound in at the center of these structures. So you have to watch what you're looking at sometimes. Again, looks like it's bound in. What is it? Cadmium. Now, cadmium is stupid heavy, and it really does have a signal for cadmium. Anyway, it's much of a muchness for most of the sample. Here, what have we got here? Again, 34.6% by weight cadmium. Could be contamination, don't know. The reason I'm showing you this sample is that John Hutchison's technology will be essentially the same thing. John Hutchison used a disruptive discharge generator and static electricity effectively in the form of either Van de Graaff generators or Tesla coil devices and RF and radioactive sources. Again, the cadmium's there. So when we go back to Brock's work and we go through that, we have some weird things going on here. Look at that little structure there. It's not tungsten, it's a sideband of silicon. But anyway, copper, nickel, calcium, potassium, sulfur, silicon, aluminium, magnesium, sodium, carbon, and oxygen. And this is inside the yang side, okay? So it's there, it's that structure there. And this is me doing the mapping before it crashes. Look how beautiful these fronds are. Where is it? Unfortunately, this map died when the thing crashed. Let's see.
This is where you...
I will share this video when I processed it, complete with my getting upset because of the thing. Look at these. 1, 2, 3, 4, 5, 6. Look at those angles. That is 120-degree angles. Perfect. 120-degree angles. Can we learn from that? Maybe. Look at these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. What are they? Right. If you go and look at the video I shared earlier today, I show you what they are. They are essentially iron and nickel. They're magnetic components of the material. Okay, so there we go. All right. I'm going to have a look at your questions now. How does the understanding of the control of matter, this science of God's toolbox, sit with different levels of consciousness and our ability to transcend this material realm? Oh dear, that's a big question. I've got to get on a plane in a few hours. Drones worldwide. Oh, I just think that's a load of nonsense. It's just nonsense. They're just trying to ramp up stuff. Yeah, it's a big question. Maybe a whole stream on that. Are there any reactors out there that simply use this effect to boil water? Well, there was the Ivan Filimenko reactor from the 1950s, but no. There are reactors that use the underlying magnetohydrodynamic structure to produce water. That is the Binge-Huang reactors. It is also the Kladoff reactors. It is also the Griggs reactors. It is these kind of cavitation systems can do it. I think ball lightning is a natural thing that can be made, but the scaring is like a nest for more plasmoids to use, holding them for longer. Maybe. Well, yeah, it's a structure made out of plasma toroids, yes, but they're more interesting than that. Image 8 looks good. I haven't shown you all the images, so let me show you the images from that. Quit Final Cut Pro because we don't need to look at that again today. Just bang you through all of these, right? Image 8, this one, there we go. It's a lovely one. Is that the one you wanted? Okay. Could this be used for the production of complex geopolymers? The question is, does the etheric matter allow for fluidization of ionic ceramics? Yes. Can you create an intense beam of these things? Yes. Have we found out an effective way to produce enough flux of these things to manipulate matter in the modern world? Probably not, maybe. I don't know. Where do you see this taking humanity in 5 years? I think with the right money in place, the right people in place, we have unlimited energy. if you understand this next thing that I'm going to tell you, you will understand how you can make unlimited energy. Maybe. On the yang side, it's separating some matter. It forces it round in the phallico-soliton, and some of it gets re-yinned into normal matter. Something might happen on the path round, and then a part of the etheric matter is expelled. But when the music stops, all of the matter becomes ordinary matter again. So what you know in this process is that a flux of this hidden energy within matter is released into a beam, but at the end of the story, potentially, all of the original atoms regain their cluster. I will explain more later. See if you can work out what I'm thinking from that. Does this structure immediately create on this vacuum? No, it takes a bit of time. Go and look at the my discussion with Griffin that I posted just before this live stream. You can go and see it on the blog at remoteview.icu or on the YouTube for the MFMP. Gonzalo Chico, hello. Did any of the people doing research describe a method to control the rate and type of transmutation results? You can reach a certain... Yeah, so Kladoff showed how you can create more elements, just not necessarily specific which ones. If you want a targeted output, you would need to have certain reactants in place. And that would come with heuristic development, but after a while you'd know. And if you look at our reaction calculator at nanosoft.co.nz, thank you, Philip Power, thank you, Dr. Alexander Parkhomov, you can use that as a guide. And if you want to create certain precious metals like Au, the elements that were chosen by the alchemists were the most likely to produce those elements as a proportion of a whole load of other things that would also get produced. And so in this analysis, we found some silver and tin, I think. We found silver being produced in cavitation experiments before, in ultra experiments. And so I think that's probably something that gets produced, but like maybe different elements in play would produce different elements. Maybe I can do the -2 towards here. What shall I do here? I will do a no yin. And I won't do a yin at the moment. And I'll do sub n -1 tor. There we go. It's actually in the wrong place, but it's okay. No. They are the sub n -1. Okay. Okay, this one. When you understand these flow patterns and what they will create, it might make more sense what's going on with the overall weirdness that you see on the electrode. Okay. So Gonzalo is asking about but why did it stop being used? Apparently there was a war about it, and then someone came in that won, and they disabled it by taking some things out. That's what I've been told, was apparently in some Sumerian texts. I don't know, I've not confirmed it. Trapzilla says, Bob, let's jump 50 years from now. You think there will be a cookbook for elements making scarcity null? Yes. I don't even think it'll take 50 years. It just needs people to try. People like Griffin Brock, just to think, was Tesla an idiot? No. Was Tesla actually making things that look like X-rays, but he didn't die until he was 83 or whatever it was? I can't remember. But he died quite old, right? Yes. So what did he actually make? Well, no one's going to tell me, so I have to go and try. Well, with what the project's done, the project has tried to find whether there was any truth in low-energy nuclear reactions. It did that in a month. It then tried to find out potentially what was going on. That took a few years, several years. And then it tried to find out whether there was any supporting evidence for that. And I believe that's where we are. I think we've brought everything together. Unification is in this particular electrode. It shows the same thing going on in Ultra, but it shows the same thing in a more visual way that I think might be on the threshold of some universities willing to look through the microscope. They might want to do it, right? My proviso is the provisos that I gave in the video that I did when I was discussing with Griffin earlier in the week. You know, I want to see some blank electrodes. I want to see some non-spot welded electrodes. I want to see some electrodes where it's held in a different way and so on, and see if the same things are occurring. But given the fact that it's producing this radiant energy, the radiant energy is the magnetotor electrical clusters, which can present as positive or negative static electricity if they're carrying electrons and ions, or ions and electrons respectively. Or it can be neutral. It can be neutral because of charge balancing, but it could be neutral because of of matter coherence, or it could be neutral because it's not actually carrying any ions or electrons. So we know that it's producing this, and we know that low-energy nuclear reactions have been producing this since forever. And so everything is brought together. This will allow unlimited energy at any point in the universe. It is the wheelwork of nature. I'm 100% certain in my own mind, and have been for quite a long time actually. And this will allow propulsion at any point in the universe. And because this is, as you move forward, you get access to more of this rarefied material, and so you can capture more of it. So the faster you go, the faster you can go. There's no reason why this will not allow faster than light travel. And because it changes the dielectric constant of the physical vacuum, the permittivity of the vacuum, you will be able to, effectively warp space. So Skoggy Hoggin says, what's a better way to attach the nickel if soldered? I'd like to see maybe just it captured, you might be able to cut little bits of around the edge of the aluminium and then hold it like with three points. Just hold it 3 points. You might even be able to make a thicker piece of how should we do it? Like the actual electrode is just quite thick. Whether it's a resonant thing, it might be. It might need to be the thickness of the subtor that you can see here, for it to work effectively. So these things need to be tried. But whatever. There's many ways you can fix things. Actually, I don't know whether you need to learn everything. You just need to try. Yes, it'll upshift the infrared to visible and visible to blue and so on, and UV soft X-rays. It's a pleasure, Scoggy Hoggins. We have an absolutely beautiful future ahead. Absolutely beautiful. If they stop using this technology, to subjugate us, we need to do like Griffin Brock has done. Do. David Boutelier has done a lot of characterization of the radiation. This is a characterization of the electrodes. Griffin has done characterization of the radiation. There is a huge amount of experimentation that can be done with these tubes. Huge. Huge. I would get yourself in the queue for getting one of these tubes. Now, I've said to Griffin, you can see in the discussion I had with him early in the week, he probably wants to sell the whole kit because he clearly has been able to demonstrate this repeatedly using the kit he has. Some certain aspects were not able to be produced by David. The first tube he got had a hole in it, but Griffin was gracious enough to send him a new one. The second tube, he's certainly seen the radiation travel a large distance. I'll let David speak to him for himself. But he's not been able to do the real-time X-rays. I think that's probably something to do with the image intensifier and the choice of video camera that he's using and so on. So we shall see. Hi, Ashton. Ashton is in the house. Right, so I will do a brief overview of what we've gone through today. This was Ode Unification. And this is our yin, our mother, our Gaia, and she's in this icy condensate of relic neutrinos. And what we believe we have done is we've shown categorically, I believe, that the magnetohydrodynamic structure can de-Thaw this condensed clusters of relic neutrinos and actually make it into a fluid. And it's beautiful. It's beautiful because when you get that fluid in motion, you can do utter magic. And the crazy thing about this is that Gaia, in the Greek legend of the beginning of the world, worked with Uranus. And these are the symbols for Uranus. And oh my God, does this not look like a vortex and an anti-vortex and the material being pulled up through? It really does. And so we have shown that on this particular electrode here, there is an area of which I've identified years ago and have been very clear about this. But in this particular electrode, we can see that the material outside of the affected area here looks like just brushed with little bits of iron flecks in there. It's largely the same in this particular area of this structure, of the magnetohydrodynamic structure produced by Griffin Brock, which we know produces radiant energy, which we know is magnetotoroelectrical radiation. And I've said that this is the safe area in the ARV, and if you put the ARV in the place that it must exist, the central column, you will have a dense flux. Just like you've got a flux coming out of the center of here, you will have a dense flux going through the center of here. That is what provides your spike of high-frequency gravitational waves that will come through the center, but it's the cohering of the cosmic flux that's coming in on the bottom here. And if there's any chance of some of that reaching the passengers, that has the aluminium disc, which we know stops it in this experiment, and we know can be a use for shield. It was used by John Hutchison to capture and or reflect these things. They are partially reflected. By having the spinning disk here, any charge clusters coming in, any relic neutrino condensates, any magnetotor-electrical radiation will get caught by the aluminium and thrown out and accentuate the magnetohydrodynamics going on. Okay, so that is your safe zone in the alien reproduction vehicle. Okay, we have shown the ridiculous actual preciseness of how it's moving this fluids around in these structures. How? If you take out the sacred geometry, you have the fluid flowing in here, the fluid flowing in here, the fluid flowing in here. And because we know that and have assayed that this is nickel and iron, these are the magnetic flux lines coming in to the magnetic flux capacitor, which is in the central part of here and here. Okay? And we have shown in this electrode that where the magnetohydrodynamic outer vortical pattern meets the center of the one on the left, this here, we can go and put the yin in here. You can see that exactly and precisely where that meets, you have the central vortex part of the pattern inside the fractal n-1 torr. Okay? And that if we look at this, it's really rather beautiful. Again, here you can see you've got this is the aluminium here, aluminium, carbon and oxygen. This is the iron and the nickel. These are the flux lines coming into the flux capacitor. Okay, in here you can see there's a much higher density of heavier elements inside the torus. Inside the torus. In this area, you've got things like lots of copper and iron and nickel, much more than you have out here. Okay, because this is where the main flux capacitor aspect is going on. Okay, and we can see by the 3D geometry over here with the depth, you can even see these flux lines coming in. Okay, and if we look at some of them, they have this twisted nature going on. Twisted, twisted, here twisted. Okay, and it's deep pitting in here. This is a hole, it's a hole in here because matter is being moved at this point. Now, we worked out how many substructures they had. So firstly, we know the diameter of this is across the apple is 15 millimeters. That would make this structure even bigger actually than the one that we saw on the Lion reactor. Going through the center of this and going through the center point here, that is that scale. And if we go to the number of angles per torr, we take the center point and we draw out through the corner here and the corner here. We get 45 degrees, divide by 3 because we've got 1, 2, 3 petals. That's 15 degrees. That gives the number of n-1 torrs at 24. Okay. Going back to the PSD, we have a exact correlation here on the yang side, in my view. This point here is where lighter elements will typically be formed. And if we go to the SEM, we found that all of the elements that are typically produced by stars are bleeding out of the center of this triangular nickel and iron flux core. Coming out of the center. And these are exactly the same elements that we see coming out of the magnetohydrodynamic structures, of which they are thousands and thousands per square millimeter on the heat-producing and element-producing reactor of Binjuin Huang. Okay? So they're spewing out. So there's definitely transmutation going on in here, and this precise point here is exactly the same point as you see in the magnetohydrodynamic structure of the ultra experiment here. Okay, this is where heavier elements are formed. Okay, so this is boron crystals, no calcium there. There's some silver down here. There's calcium here and no boron. Oxygen removed from aluminium makes boron. Add oxygen to aluminium and you get some isotopes of calcium. And if we pull that back here, actually I'm going to put in this one. No, not this one. I'm going to put in the yin here. So you can see the same kind of shape that ends up giving you the bar spiral galaxy. But if we put down the whole structure here, this is where the material comes up to. Now, if I'm going to go to the 3D geometry here, or rather the relief that I took with the macro photography, you can see how deep that goes. So this is really a pit that's been taken out inside this. Really, quite a lot of material has been lost, and I think that material potentially has partly been converted into the stream which produces the X-rays type images that Griffin Bock produced. This is where elements are shifted to, and this is raised, so you can see the shadow over here. So this is actually up, and this is pit. This is up, and this is pit. If you condense matter, it gets denser, and so it will start to pit. If you are inflating matter, then it will get bigger and rise up like a mountain. Yeah. So I think what's happening here potentially is you're getting lighter elements synthesized, and over here you're getting heavier elements synthesized. So this is a compressive over here. This is an expansion. And I would imagine that from the yang feeding to the yin, there's a phallico-soliton. And we represent that in our 3D geometry here. And the counterflux of etheric matter is coming out from one side, not the other side, because the other side goes into the plate. So you only get it from one side. And the flux loop, if we put it in here, is here. Okay, so it'd be over there between these two. And I've said that probably this is slightly off from directly parallel, perpendicular rather, to the tube length. And that's why you don't see any particular destruction because of the subcone in the disruption zone down here. It's not interacting with the plate that much. Okay. What we've also noticed is that if we come out and we go here, that this blue area here is essentially just outside this circle, and this circle. The brown area here, or the goldy area, is just outside this. In fact, it's on the line, on the line, and on the line. Very, very precise here. The actual overall sphere of the structure, which is the non-radiating boundary, the inner layer of the double layer of the non-radiating boundary, presents itself as this there. Okay, so that's the inner layer. The outer layer would be here. That would coincide with part of that. But I think that's really not, that's probably what's causing the location within the tube. Okay, so the tube would be maybe here and it's keeping it bounded there, but it likes to be here for whatever reason. That's the point of resonance. It wasn't resonant here and it wasn't resonant there. It was only resonant here. And so you get the transverse to the because you always get a node which will be a standing wave node here, and then you get the structure forming transverse to it. Okay. And we want to get rid of the main cone. No, we don't want to get rid of that. We want to get rid of the outer shell. And we will get rid of main tool. Okay. Yeah, so what else do we have here? I showed that the damaged areas here, which I thought were initially potentially because of the spot welding process, I think are actually compatible with the actual magnetohydrodynamic damage. So if I show you again, these kind of damaged areas here, okay, which we can see on the 3D relief here. And so if I go back to this one here, all this damaged area here, this is quite deeply in with lighter elements or whatever. And the same kind of thing is going on here. Okay. We had a look at the fact that these particular lines here, around here and around here on color imagery, and again on this color imagery here, you can see there's just a few of these lines clear where you have the iron and nickel, you know. It's definitely less clear than it is on the EDS, right? So you're only seeing very few on this side. Over this side it's a little bit better represented, but it's still a poor cousin, really. There's a lot more lines very clear. And just to reiterate, this for me is one of the most amazing parts of the structure, the fact that this beautifully comes in and does not interact with this. And it's just weird to think that nature is so precise, but it is just so precise. It has one plan, one plan. So the flux line's coming in here. This is the next level, this is the next level, and this is the inside. And there's even a layer around here, which is where the torus sits, the subtorus sit. Okay. Over this side, I didn't really talk much about this side. You can go and look. I analyze one of these. Again, more data will be available. But this is like solar prominences. You can see it's kind of like, it's kind of folding over here, folding over here. You've got a flux loop going around here. But ultimately, they kind of roughly point into the center as you go round. It is a thing of great beauty. Okay, I'll take any last questions. Hi, Bernie. How you doing? So the Egyptian pyramids could act as the lower cone. Go and have a look at A New Dawn of an Old Age. I explain the pyramid, what I think there. And honestly, seeing this electrode absolutely categorically nails it for me. It unifies the pyramid. It unifies Tesla's Wardenclyffe Tower. It unifies the radiant energy, the etheric matter rays. It unifies Lena. It unifies the ARV. It unifies how we can go faster than light, how we can get unlimited energy. It unifies how the universe can make and break and deliver all of the magic you can possibly imagine. And it's like the cherry on the top, the cherry on the top. I believe that the pyramid is throwing a etheric matter beam one way and the other way. Okay, because these things are like a magnetic flux in their own right, they will probably fold around the planet, and there will be repeater stations. I'm speculating, but not without some idea, that this might be a system that when the pole reversal occurs, which might be in the 2030s, if that's going to happen, then we would need to have this in place to prevent the disasters that might occur as a result of that. Because we might get a huge ejection from the sun. So we might need to protect our atmosphere. Yeah. Actually, it was someone sent me. I don't know. It's this guy called the Diebold Foundation, and you can go and read it in your own time. It's called the Diebold Foundation. Die, as in DIE, Hold Foundation, and they are talking about the pole reversal. They say there's 7,982 days, but it might start 7 years before, which I think is in 2037 or 2038, something like that. So I don't think, if we haven't got the pyramid functional by 2032, I think we are going to be, not in a good position. If this is true. Now, there's some things in here that, like, I go, yeah, okay, all right. I'm not overly convinced about. But the plan is to go to Egypt and speak with the relevant authorities and see what we can do. And the work of Gigi Brock on this Tesla radiant energy device, etheric matter ray device, which we have verified, in my view, as a magnetohydrodynamic structure, doing the business that we need it to do. Is for me unifying all of my understanding over the last several years. Yeah, it might not be a bad, but like I'm still bought into the fact that we might have coronal mass ejection, and so I just, I'd like to have that option in place. I would err on the side of caution. I think the device was gifted to us, and possibly it saved the planet from several ejections, and it didn't save us from the last one, which Robert Schoch says is probably what caused the Younger Dryas period. So. Oh, great. Excellent. Bernie. He's going to Tesla Tech. What's a good way to protect from radiation when running the same machine as Griffin? Would you kindly elaborate a bit? Yes, I have a shield. You can go and have a look at it. I do a video on it. And I have multiple layers of aluminium and cellulose, and ideally you either ground the aluminium or you charge it negatively to excite the clusters so that they are then captured in the metal. I can talk about what I can talk about. I can't talk about things I haven't considered. It would just be pure speculation. Orgone energy is exactly the same as this. You can read the bit that Shishkin writes, and I fully subscribe to Shishkin's view that orgone is the same as ectons, is the same as evos, is the same as charge clusters, is the same as radiant energy. But basically, it's static electricity, and the neutral form is the magnetotor-electrical radiation. Okay, I will upload the some of the images. I will upload some GIF animations of these various things being overlaid and so on, so you can see the whole different imaging approaches that I used to studying this electrode. I will screen grab, because I only have the video, some of the analysis, other than the 3 pieces of analysis that I did after I'd identified the crash. And I'll upload for those people that have a PC, the software and the deep zoom image, so people can study this structure. I think there's a great opportunity for someone who's good at statistics to study the arrangement of these structures in here, and to find out, let's say there are 24 here, how are the various ones interacting? And like I say, we've seen these same kind of scratchy marks on the fuel of Suhas Raukar. And I need to go and revisit that sample and take a view on it. But with this data, you'll be able to study, I think a lot of these are very specific angles, like it's like 120 degrees, 120 degrees, 120 degrees, 120 degrees, 120 degrees, 120 degrees. There's something definitely interesting going on here. These scratch marks typically have 6, but some of them have got more, but then you could consider it's 2 traveling together. Okay. Thank you very much, Muggle. It's very kind. Yes, cat furry makes static electricity go purr. Yes, very good. Yes, I like it. So yeah, someone can maybe work out why you have these bits go over like this. This is similar to the outside of those structures that you see, these kind of curved bits with sharp edges on the outside of the structures in Binzhen Huang's reactor. So why is this? I mean, are all of these at a particular angle? Is this 60 degrees? I don't know. Is it 120 degrees? Is it all divided by that? Let's do some angles on here. This is the sort of thing you can do with this tool. So let's assume these two things are related. What angles are they? We can go there. We can go up the center line of that one, let's say, like somewhere like that. And we can come down here and we can grab the other end of this and we can go like that. And it's gone 320. So that's basically, is it whatever, 360? That would be 40 degrees, is it? I don't know. We can go and do another one. You see, what's the angle between these? It looks like about 120, doesn't it? There seems to be quite regular angles here. Let's see. It's going to give me the wrong angle, isn't it? Can we do it like this? Okay, let's try that. Yeah, approximately 120 degrees. It depends where you take the center point from. Is it there? I don't know, roughly. So people can do some statistics on that. They will have this to be able to study. What programs would I need? Where is it going to be posted? It'll be posted on Remote View. The software to view this, it is going to be free. You just load it and then you load the deep zoom image. You can do the statistics. You can measure features. I mean, there's a real opportunity here for you guys to do some real science on this physical data that's been captured from this magnetohydrodynamic structure, which in my view is the key. And I can only imagine that if this is true and it is replicated on another electrode, that repeatedly we are going to get to see, because it's already so absurdly precise, in the placement of everything. It's so precise where it's placing stuff. So, I imagine that we're going to see more of these kind of same precise placements. And it would be hilarious if everything is exactly in the same place. But, there's always variability, the angle, the tube, the frequencies and whatever. But I suspect that we're always going to see flow coming in here, flow coming in here. We're going to see different event horizons, event horizon, event horizon, event horizon. We're going to see the kind of this event horizon, just like we see on the material from the cardioid infarction from Henk Yuan. Thank you, Darren. That's absolutely fantastic. That really helps. Yes, they do. Yes, that's true. Odd One X saying it looks like strange radiation emitted from Vega experiment. Does water molecule have 120 degree angles? I don't think it's far off, actually. Yeah. Douglas Vogt also said the interesting scalar-like model. Okay, did he? I didn't know that, Joe. Thank you for letting me know. Scoggy Hoggins, data guy here. More images from different samples will tell us more. Yes, of course. I want more images. That's what I've asked for. I've asked for more run samples and more samples that are not run. Okay? Okay, so, and I love the fact that this data really points to the ARV having to sit there. Having to sit there. Yeah, so it's not 120. Thank you, Scoggy Hoggins. How much donation do you need per video to achieve your goals for family? Oh dear. I need to think about that. God. I'm probably going to have to give it a. Thank you for that comment. I'm probably going to have to. Oh dear, that's very kind of you to suggest something like that. I'm going to have to probably get on the plane. I've got a bus in about an hour and a half. I need to get home, get my thoughts settled. I need to collect the other things that I need for the experimentation in Canada. But I want to have a personal thank you to Griffin Brock. Griffin, thank you very much for sharing your device with first David Butlier and second myself, this electrode. Thank you for your offer to send me the blank run and adjusted run electrodes. I look forward with great trepidation on study of those electrodes. I think you've done an amazing job, and like I said earlier in this presentation, it's the cherry on the top. It unifies all of the things that we've been learning over the last 7 years with regard to this magnetohydrodynamic structure, and the potential for the future of humanity is incredible. I can understand why Tesla was so visionary about the things that he said. You know, the flying machine in 1911, the source of unlimited energy. Really, it is those things. And we are going to do this for ourselves. The cat is truly out of the bag. And we are at the dawn of an old age. Thank you very much, Griffin, for your work and your passion that has made this presentation a thing that's possible. It's my deep honor to have been able to study your electrode, which I've been able to present today in this presentation. And so, with that, my friends, I will say, this was Ode Unification, 7th of December 2024. And Yen, you've given up your secret. It's the age of Aquarius is upon us. Thank you, double and odds, buenas noches, good night.